In the last section of videos, we talked about emission particles. They appear, react to forces, and eventually die over time. But there's another type of particles, hair particles, that we can also apply dynamics to. One thing you want to note is that I am using Blender version 2.77, so if you're using an earlier version, you'll have to update in order to follow along, since some of these settings are fairly new. To add particle hair to your object, go to the Particles tab, make sure your object is selected, and just click New. Then at the top, switch from Emitter to Hair for the type. Now we've got some sweet strands, but if we play back our animation, you can see that while they are stuck to the ball, they're static and don't react to gravity or any other forces. So to enable that, just click the checkbox next to Hair Dynamics. Now when we play this back, these strands will bounce around and react according to these settings here. Now before I get into what each of these settings does, I want to talk for a second about steps. If we zoom in really close on our strands, you can see that they're each made up of a bunch of little lines, and the number of segments is determined by the number of steps. But there's a few different places that we can set the number of steps. One of them is in the bottom of the Hair Dynamics panel. This is the number of steps that Blender is using to calculate the simulation. However, that's not the same as what we're actually seeing in the viewport. So to change that, let's go down to the display options. Under steps, let's change this to 5 to match the steps of the simulation. If you want to change the render steps, you can also do that as well under the render options and change the steps from 3 to 5. Now that we can see our strands more clearly, let's go over what each of these settings does. The settings for controlling how the hair acts are divided into 3 sections: structure, volume, and pinning. The structure settings control how much the hairs bend. The mass value controls how heavy the hairs appear to be. Lighter hairs don't bend as much because they don't have as much mass to pull them towards the ground, and hairs with more mass seem to flail about more because it takes more force to keep them in place once they're moving. The stiffness value controls how easily the hairs can bend. A larger value will result in wider angles at the bending points, and smaller values will result in tighter angles. You can also set a random value to give your hairs a little bit more variation. The number sets the percentage that the hairs are allowed to deviate below the original stiffness value. Increasing the damping value will increase how resistant the hairs are to bending. A high damping value will try to always keep the hairs as straight as possible. Now the volume settings have to do with how the hairs interact with each other. Since there could be way too many points to calculate real collision in a reasonable amount of time, Blender uses the volume of the hairs to approximate how they would interact. The reason a piece of paper doesn't fall as fast as a rock is because air has some resistance in itself. Increasing this air drag setting will make the air seem thicker, which makes the hair a little bit slower to move. If you set this to a high value, it's almost as if our furry ball is floating in water because the air is so thick. Internal friction controls how much a hair allows the other hairs around it to move. It's essentially like adding hairspray to the simulation. Target density generates an outward force on the hairs that are close together to prevent hair from collapsing in on itself. It's like rubbing the hair with a balloon. The higher the target density value, the more dense the hairs are allowed to be. If you use too low of a value, the hairs will freak out and wiggle around a bunch because they're trying to reach a density that is technically impossible, but they're still trying really hard to reach it. The density target also only works with at least some internal friction because they need to know how much they can move around in order to get to that desired density. The voxel grid cell size determines the quality of the volume calculations and does not affect the structure settings. You can see the cell size in the viewport if you enable hair grid in the quality settings. If all of the volume settings are at 0, it won't show up since it isn't being used. Remember, the density target is measured using this setting, so the lower you set this, the less dense the hair will attempt to be. The default setting of 0.1 made my simulations pretty slow, so I cranked it up to 1 for most of my tests. You'll only need a small value for this when you have very detailed hair. And lastly, the goal strength pinning option determines how much the hairs try to keep their original shape. Even if they get bent and messy from the simulation by colliding with other objects, they'll still try to find their way back to where they started.